Let's take a look at some sample problems from section 12.5 on the normal distribution. I'm working on the exercises from page 675 in our textbook, and we'll begin with number 2. For the problems requiring calculations of z-scores, we're going to be using the table 17. Calculators will do some of these computations, but we're going to stick with the table and the empirical rule. And so in our first group, we're asked to identify the quantity, the variable quantity, as discrete or continuous. So in number 2, we have the number of babies born in one day at a certain hospital. Well, that's going to be a finite number of babies, and we can actually count 0, 1, 2, 3, 4, and so forth. So that would be discrete. In number 4, the heights of seedling pine trees at 6 months of age. Okay, because the heights of trees can vary, can be a fraction in between, they grow continuously. We're going to find that's a continuous answer. Continuous O-U. I got my letters mixed up. O-U-S. Okay. Number 6, the time as shown on a watch with a sweep hand. There again, with a watch that has a sweep hand, the time is continuous. That sweep hand can be at a fraction. So that would also be continuous. Still correct. Continuous. Yes, that's right. Okay. Number 8. We are looking at, suppose 100 geology students measure the mass of an ore sample. Due to human error and limitations in the reliability of the balance, not all readings are equal. The results are found to closely approximate a normal curve with mean 86 and standard deviation 1. And we're talking about grams there. Use the symmetry of the normal curve and empirical rule to estimate the number of students reporting readings in the following ranges. Okay, as you get to these application problems, any of these problems dealing with the normal curve, the first thing I recommend very strongly that you do is draw the normal curve. In this case, we're told the mean, which is the middle number here at the peak of the graph, is, and then our standard deviation is 1, so we add 1. We add 1, we're up at 2, we want to go up 3. Okay, so that's 81. Then we want to subtract 1, subtract 2, and subtract 3. Okay, so we start with that drawing. Now we look at the questions number 8 and 10. We can use that drawing for both. And it says, okay, just we want to remember these are 34%. Okay, and let's see, I think it was 13.5%. Okay, so that's 68 plus 27. That would be 95. That's right. Okay, and I believe the next one is 2.2. And then we have 0.1 or something like that in the... Okay, so let's look. In number 12, we want... No, in number 8, we want more than 85 grams. So we're talking about this percentage here. Well, remember at this point we have 50% to the right and 50% to the left. So I need to add the 50% in this section here. So let me shade it so we can see what we're looking at. I like to shade them. Okay, so that's what we're looking at. So 50 plus the 34, 50 plus the 34 gives us 84%. So we have 100 students times 0.84 is going to give us approximately 84 students. Okay, between 84 and 87, get a different color. Between 84, nope, it didn't change. Between 84 and 87. Okay, so we're looking at 34 and 34 is 68% plus 13.5% and 11, 81.5%, so I'm going to round that to 82% since we can't have half a person. So 100 times 0.82 is about 82 people. Okay, and the book says 81 or 82. Number 12, we have IQ scores, so I need a new normal curve to work with. Okay, and it says the mean IQ score is 100 with a standard deviation of 15. So okay, and so this would be 85, 70, and 55. Okay. So now we want to know greater than 115. Let's go with yellow this time. Greater than 115. Okay, so I'm going to do a little subtraction here. I know that we have the 50 plus the 34. We have the 50 plus the 34 is 84%. So we have 84% to the left of that line. So if I take 100% minus the 84, I'm going to get the shaded region, which would be 16%. So 0.16 times 100 would give us about 16 people. Okay, and they want it as a percent, so I'll leave it as 16%. So make sure you read carefully when you go to put your answer in my math lab. More than 145, so we're talking about this little region right here. Okay, and as I recall, that is something like 0.1% times, okay, 0.1% would be 0.001, and that would be times our 100. It's going to give us a 0.1. That's right, we're supposed to leave it as a percent, 0.1%. So it's a very small number. In this case, 0.1% of 100, we wouldn't even get a person since we only have 100 to start with. Let's see. Actually, they don't tell us how many people. Alright, so in our next group, what we have is we have find the percent of area under a normal curve between the mean and the given number of standard deviations from the mean. Note that positive means above the mean, while negative means below the mean. Okay, so we're doing these as percentages. And you'll notice again, I'm still drawing the picture. The mean, okay, has a z-score of 0. That's important to know. And 0.92 is the very first one. So we're looking for the area of this. So we turn to our table 17. And what you'll notice is the z-score is in one column, and to the right of each z-score is an area. That is, and you can see in the shaded graph to the left of the table, just to the left, that is the area that is given each time, from the 0 z-score, which represents the mean, to the z-score. So in our case, we want to look up a z-score of 0.92. Okay, and that's in the second column of z-scores. And 0.92, I see the area is 0.321. So it gives it as an area. We need to change that to a percent, since the question is asking for a percent. So we get 32.1%. All right, the next one in 18 is negative 2.25. And I'm a very visual person, so you're going to see me drawing these. And I encourage you to do it as well, at least until you know what you're doing, and maybe even after that. All right, so from the mean to negative 2.25. Because the graph is symmetric, notice that we can look up a positive 2.25 to find that area. So you need to find the z-score column that contains 2.25. Okay, and the area I'm seeing is 0.488. All right, so this area is 0.488, and as a percent, that would be 48.8%. Okay, we'll continue with some additional problems in the next recording.